We saw in last week types of induced EMF. So that is classified into dynamically induced EMF and statically induced EMF. So when conductor is moving inside magnetic field, so whatever EMF induced, that is called the dynamically induced EMF. When we are keeping conductor stationary and that comes in interaction with magnetic flux, so EMF is induced, that is called the statically induced EMF. Again, statically induced EMF that is classified into self-induced EMF and mutual induced EMF. Okay, so this is the two conditions. Accordingly, we can say this is dynamically induced EMF and statically induced EMF. So conductor is moved in a stationary magnetic field, that is called the dynamically induced EMF. So when conductor is stationary and flux linking with the conductor, that is called the statically induced EMF, and it is furtherly classified into self-induced EMF and mutually induced EMF. Self-induced EMF means a coil linked with its own turns, that is called the self-induced EMF. Mutually induced EMF means we have two coils, so one coil linking with the other coil, that is called the mutual induced EMF. So we saw the equations for dynamically or mutually induced EMF. So this is N and S for magnetic pole is given, conductor is given in between. Here we have taken uniform magnetic field. Okay. So here the velocity that is divided into two components, V sin theta and V cos theta. So V sin theta is perpendicular component. So due to that, flux is cutting. So we are getting this induced EMF is equal to d phi by dt for this mutually or dynamically induced EMF. So this is E equal to BLV according to this when conductor is moving inside the magnetic field. So dynamically induced EMF is equal to BLV, where V is equal to dx by dt, that is taken equal to velocity. Statically induced EMF, self-induced EMF, mutual induced EMF. So you can say this, we have only one coil, so it linking with its own turns. Okay, so we can change this magnetic field by changing this resistor value. So we change this current value, and according to this, we can change this magnetic flux in the circuit. So we'll get E is equal to L di by dt, but we are taking E is equal to minus L di by dt according to the Lenz's law. Mutually induced EMF. So we have two coil A and B. So when we give battery supply to the coil A, so here we have current. So due to that, magnetic field is generated. So that link with coil B. Okay. So due to this Faraday's law of mutual induction, we'll have EM is equal to M di by dt, but we are considering EM is equal to minus M di by dt according to the Lenz's law. Okay, this is by Faraday's law, but the minus sign comes due to the Lenz's law. This is the difference between statically and dynamically induced EMF. Okay. Coefficient of coupling. So here when two coils are linked, so how much this coil is coupled, or how much magnetic flux that is shared, so that is called the coefficient of coupling. Coupling is nothing but the connected, how much both coil are connected by magnetic flux, so that is called the coefficient of coupling. So that is denoted by K. So K value that lies between 0 to 1. Okay, so 0, K equal to 0 means both coils are isolated, so there is no linking of flux between two coils. Okay, so here written this both coil 1. So here on the right hand side you can consider this coil 2. Okay, if K equal to 1, then you can say this both the coil are tightly coupled, means here maximum flux is linked by the two coils. Okay, so here K is equal to M under root L1 upon L2. So this is the equation for coefficient of coupling, and K value that lies between 0 to 1. So K equal to 1 is equal to coils are said to be tightly coupled, and K is equal to coils are said magnetically isolated from each other. So this value lies between 0 to 1. So accordingly, you can assume how much flux or magnetic flux is said, or how much these both coils are coupled. Now we'll see self-inductance. Okay. So self-inductance means the property of coil due to which it opposes the change of current flowing through itself is called self-inductance or inductance of the coil. So it is the property of inductance that it opposes the change of current flowing through it. As we know, the nature of inductance, it stores the kinetic energy, or it stores the current value. Okay. So it is a passive element. So when we supply the voltage, it stores the kinetic energy. Okay, and when we stop the supply, then it delivering this current to the circuit. So in terms of delivering, when voltage becomes equal to zero, still it delivering this current. Okay, it doesn't any change in current. It still it has stored this kinetic energy. Okay, so the property of coil due to which it opposes the change of current flowing through itself is called self-inductance. It stores the kinetic energy, or it stores this current value. This property is attained by the coil due to self-induced EMF produced in the coil itself by changing the current flowing through it. Now we'll see if the current is increasing or decreasing the circuit, then what will happen to the self-induced EMF. So if the current is increasing, the self-induced EMF is produced in the coil in such a direction so as to oppose the rise of current. Okay. So when current is increasing, it opposes the rise of current. On the other hand, if the current is decreasing, the self-induced EMF is produced in the coil in such a direction so it opposes the fall of current in the coil. So there is a rise in the current and decay in the current for the inductance. So accordingly, it opposes the rise of current, or it opposes the fall of current accordingly when current rising or decaying in the circuit. In fact, the self-inductance does not prevent the change of current, but it delays the change of current flowing through the coil. It is not preventing, but it can delay the change of current flowing through the coil. So the self-inductance only opposes the changing current and does not affect the steady current. Okay, so it opposes only the changing current. It doesn't have any effect, or it doesn't affect the direct current in the circuit when flows through it. So it is defined as flux linkage per unit current. So self-inductance L is equal to N phi by A by I. Unit of inductance is Henry. So this is your self-inductance. L is equal to N into phi by I. Same mutual inductance. So we have two coils, so that is mutually connected. We know that magnetically connected and electrically isolated. Okay, in mutual inductance, we know that any change of current in one coil is always accompanied by the production of mutual induced EMF in second coil. Okay, so whenever there is changes in current in any coil, so accordingly there will be change in magnetic flux, or there will be changes in flux linkages for the both coil. Okay, so mutual inductance may therefore be defined as the ability of one coil to produce an EMF in a nearby coil by induction when current in first coil changes. This action being reciprocal, the second coil can also induce an EMF in the first coil when the current in the second coil changes. So accordingly, current changes in both the coil. So accordingly, this induced EMF will change or link with each other. The ability of reciprocal induction is measured in terms of coefficient of mutual inductance, or mutual inductance M. It may be defined as flux linkages of coil per unit current in the other coil. So M is equal to N2, number of turns of second coil, 512, this is flux linking with the second coil, and current I1 in the first coil. Okay, so this is equation for mutual inductance M. N2 512 by I1. What is the equation for L, self-inductance?
N2 by I.
L equal to N 5 by I. Now we'll do some exercise for this magnetic circuit. So here statement is given, just I am changing this. A coil is uniformly wound with 300 tons over a steel ring of relative permeability 900 and having a mean diameter of 20 centimeter. The steel ring is made of bar having cross section of diameter 2 centimeter. If coil has a resistance of 50 ohm and connected to 250 volt DC, calculate MMF, second field intensity, third reluctance, fourth total flux, and fifth permeance of the ring. So these are the given data. So here you need to find MMF. So MMF is equal to what?
MMF is equal to N into I.
N into I. So N is given. N is given in the data. Number of tons.
Yes, sir. 300.
300 tons. Current is given in the circuit. Is current
No,
given?
sir.
So how we can find this current? According to which equation?
V equals to I.
Yes,
Yes.
sir.
V equals
V
to
is
I.
equal to I into R. So I is equal to V by R. So find out current I.
5 ampere.
I
Yes.
ampere.
I is equal to 5 ampere. Now find out MMF. MMF is equal to N into I.
1500.
1500 unit is unit for MMF
Ampere.
Ton
Ampere
ampere.
turns.
tons. Now second,
Ampere turns.
yes, ampere tons. So current is 5 ampere. MMF is equal to N into I. That is 1500 ampere turn. Now in second, you have asked field intensity. So what is field intensity? H is equal to field intensity. H is equal to N
MMF upon L.
Ni into L. MMF upon length. So here for the length you can consider the diameter is given 20 centimeter. So length you can consider length is equal to pi into d. For this magnetic circuit, you can consider this mean length L is equal to pi into d. So answer is pi you can consider 3.14. D is given 20 centimeter. So tell me answer in meter. L is equal to what you are getting? Length
0.62.
point
62.
yes 0.628 meter 0.62 meter. Okay, everyone getting this answer? Length.
Yes, sir.
Okay, so points now find out field intensity H is equal to MMF upon length Ni by L. So 1500 by 0.628. For H, for field intensity, 1500 divided by 0.628. Answer will be
23,885.
2387.3 ampere turn per meter. Okay. Third one is what ask area of? Third one is ask reluctance. So reluctance is L upon. Third one is S is equal to L upon
L
mu
upon mu
0
zero mu r
R
into A.
by area is given. Area is given or not? Hello.
No, sir.
So how to find area? A is equal to pi by 4 d square. We know the equations. Area is equal to pi by 4 d square for the circular ring. So pi by 4, this d is given. Okay. So convert into meter. So that is 2 into 10 raised to minus 2. 20 centimeter is given. So we can write 2 into 10 raised to minus 2 in meter. So tell me the area.
0.0314.
So answer is 0. What you are getting? Or suppose
0.3
0 point
310 314
0.00314.
and 3.
suppose I am keeping this similar. Okay, just I am keeping as it is. Pi into 10 raised to minus 4 meter square. Okay, wait. Just I am erasing this. What you are getting for answer? 0 point or 000?
314.
300.
Just 310. Hello?
Point 000314.
Point 000
314.
314.
4.
Okay?
Yes.
Unit is for area. Unit for area.
Meter square.
Meter
Meter.
square.
Now find out reluctance. S is equal to. So L is given 0.628. What is mu 0?
4 by 10 raised to
4 pi into
minus.
Mu r
900.
900. Okay. into this 0.3, okay, 000314. So what you are getting?
0.176.
Okay, you can write on 10 raised to power. What you are getting? 10 raised to power.
1.7
10
into
is to
10
6.
power.
Suppose I am writing 17.684 into 10 raised to
5.
ampere turn per Weber. So are you getting this? Either you get
Yes.
point something or
Sure.
Yes,
accordingly
sir.
you will get 10 raised to power. Yes, remaining one, just check your answer. You are getting or not. And we need to find flux. So flux is given by flux is equal to current I is equal to EMF upon resistance. So flux is equal to MMF upon reluctance. So MMF that is given 1500 and reluctance that is 17.684 into 10 raised to 5.
84.8 into 10 raised to minus 5.
10 raised to minus 5. Yes, good. Or I can write this, or in other way I can write this uh, 0.848
4
to 10 raised to
into 10
minus
raised to minus 3.
Weber.
Okay.
Weber. Okay. And in the last, what you have asked? In the last, what you have asked? Yes, fifth one is permeance. So permeance is equal to
1 upon reluctance.
1
good
upon reluctance.
reluctance. Conductance is equal to 1 upon resistance. So permeance is equal to 1 upon reluctance. So that is 1 upon S. So this 1 upon 17.684 into 10 raised to 5. So tell me the answer. What you are getting?
0.056 into 10 raised to minus 5.
Okay, or I can write this answer
6
5.65
into 10 raised to minus 3.
10 raised to minus 10 raised to minus
Minus 7.
minus
7.
yes minus
Minus
7.
7.
Unit is anyone? Unit of permeance?
Weber per
It is 1 upon
ampere turn.
reluctance. It is 1 upon reluctance. So Weber per ampere turn. Okay. So this is your permeance. So anyone having doubt in this example?
No, sir.
No, sir.
Okay, good. Okay, wait for one more example. I'm sharing my screen. The self-inductance of a coil of 500 tons is 0.25 Henry. If 60% of the flux is linked, okay,
Sir, your screen is not visible.
not visible. Okay, wait.
Yes, sir.
Okay. So the self-inductance of a coil of 500 tons is 0.25 Henry. Self-inductance is given here. If 60% of flux is linked with a second coil of 10,500 tons, calculate the mutual inductance between the coil. Second, EMF induced in the second coil when current in the first coil changes at the rate of 100 ampere per second. So what are the given data in the circuit? This 500 means what?
N1.
N1, good. This 0.25,
L.
yes,
L.
L1. We have two coil here. Okay, you can write L or L1.
Yes.
Okay, it's okay. This we can write L1 or L. This 60% indicates what?
512.
Yes,
5.
512 is equal to 0.651. Okay, we can write this 512 is equal to 0.651. Okay, 60% of the flux is linked with second coil of this 10,500 tons. So this 512 is equal to 0.651. 10,500 tons, that is N2.
N2.
Okay, and
N2.
this 100 ampere per second is given. That means what I can write?
Di by dt.
Yes, di by dt. Good. Now we know the equations. L1 is equal to N1 phi1 by I1. Okay. So we can write phi1 by I1 is equal to L1 by N1. So phi1 by I1 is equal to, tell me what? Just read the data, write the data, then I will share my another other screen. You need to find mutual inductance between the coil, and second, you need to find induced EMF for this mutual induction, EM. Okay. So what is the equation for mutual inductance? M is equal to, what is the equations for mutual inductance? M is equal to,
L di by dt.
N di by dt.
that is for induced EMF, mutual induced EMF. Now mutual inductance N2 is M is equal to N2 512 by I1. You are telling me for this EM, mutual induced EMF, EM is equal to M di by dt. Okay. Now according to given data, you need to find this. N2 is given 10,500. Okay. Uh, as I said, L is equal to, or L1 is equal to N151 by I1, or I can write this phi1 by I1 is equal to L1 by N1. So it is equal to, It is equal to,
0.0005.
or I can write 5 into 10 raised to minus 4. Is it right? Is it okay?
Yes.
Yes, sir.
Yes, sir.
Now we know flux linking 512 is equal to 0.651. Now I need 512 by I1 ratio. So I am dividing on both side by I1. So I am dividing by both side I1. So 512 by I1 is equal to 0.6. I can write this. Can I write this? Yes or no?
sir.
Yes.
Okay.
Yes, sir.
So just substitute this 512 by I1 in these equations. Okay. So N2 is given 10,500. Okay. And this tell me this this 512 by I1. What you are getting? You will get this 0.6 into 5 into 10 raised to minus 4. So you will get
0.315.
3 into 10 raised to minus 4. Okay. So this 10,500 into 3 into 10 raised to
3.15.
minus 4. So answer is 3.15
3.15.
Henry. Don't forget to write this unit, okay? Henry. It is mutual inductance. So unit for inductance is Henry. So 3.15 Henry. Are you getting this, everyone?
Yes, sir.
Now find out mutual induction. EM is equal to this M means M means mutual inductance. EM means mutually induced EMF. Okay. So just remember it. What you ask, either ask inductance or induced EMF.
315
Unit.
volt.
Very good. So 3.15 into 100. Answer is 315 volt. Okay. So just check your answer. Now I'm giving one more example. Anyone having doubt in this example?
No, sir.
No, sir.
You need to remember these terms and its relations. Okay. Now we'll go for this coefficient of coupling example. This example number is third. The number of turns in a coil is 250 when a current of 2 ampere flows in this coil. The flux in the coil is 0.3 meter milliweber. It is milliweber, okay, 0.3 milliweber. When this current is reduced to 0 in 2 milliseconds, the voltage induced in a coil lying in the vicinity of coil is 63.75 volt. If the coefficient of coupling between the coil is 0.85, find self-inductance of the two coils, mutual inductances, and number of turns in the second coil. So what are the given data? This 250 means?
N1.
N1.
Yes, N1. This 2 ampere,
I1.
I1, good. Then 0.3 milliweber,
5-1.
5.1, or you can write 0.3 into 10 raised to minus 3 Weber. Then this 2 millisecond,
DT.
dt. Okay, this dt is equal to 2 millisecond, or 2 into 10 raised to minus 3 second. Then this 63.75 volt
Induce EMF.
induced EMF of coil 1 or 2.
2.
Yes, coil 2, EM2. And this 0.85
K.
K, that is your coefficient of coupling. Now find out first self-inductance of coil 1. So L1 is equal to what? L1 is equal to what?
N1 5 1.
N1 phi1 by I1. Okay. So these are the data. Just I am setting my whiteboard, digital board. So in the given data, N1 is equal to 250 tons, okay? dt 2 millisecond, I1 2 ampere, or I can write this 2 into 10 raised to minus 3 second. Phi 1 is given 0.3 milliweber, or 0.3 into 10 raised to minus 3 Weber. EM2 is given 63.75 volt, and K is equal to 0.85. Okay, so first find out self inductance of coil 1, N1 phi 1. So what you are getting?
3.75 into 10 raised to minus 2.
Okay, or I can write in other way in terms of millihenry, 37.5 millihenry. Okay, now we know L2 will find by this coefficient of coupling. Okay, this L1 we found, still L2 is remaining, but we know the relation for EM2 is equal to M di1 by dt. Okay, so this EM2 is given 63.75 is equal to M in bracket, this is di1 by dt, so I can write this 2 upon 2 into 10 raised to minus 3, okay, 2 minus 0 upon 2 into 10 raised to minus 3 di1 by dt. It becomes 0 to 2, okay, so I can write 2 minus 0 upon 2 into 10 raised to minus 3. So what you are getting? M, tell me the M.
63.75 into 10 raised to minus 3.
Yes, 63.75 into 10 raised to minus 3 Henry, or it is millihenry, okay? 63.75 millihenry. Now, coefficient of coupling is given, mutual inductance is given, L1 is given. So what is the relation to find L2?
M is equal to K into under root L1 into L2.
Yes, or you can write this K is equal to M divided by under root of L1 into L2. Okay. So I can write this under root L1 into L2 is equal to M by K. Okay. So M by K, what you will get? M by K?
75 into 10 raised to minus 3.
Into 10 raised to minus 3
Ah,
divided by 0.85. So I have 75 into 10 raised to minus 3. So I can write by removing this under root, I can write this L1 into L2 is equal to 75 into 10 raised to minus 3 whole square. Okay. Now we have L1. Find out L2. Okay. So L2 equal to 75 into 10 raised to minus 3 whole square divided by 37.5 into 10 raised to minus 3.
0.15.
5.
0.15 unit
Meter.
meter. We have inductance this.
Henry.
Henry,
Henry.
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 This is inductance of Henry. So L2 is equal to, I can write in millihenry, so we'll get 150.
150 millihenry.
Or you can write 0.15 Henry. Now, flux link with the second coil. Flux link with the second coil. Phi12 is equal to, I can write K into Phi1. Okay, this is the relations for when flux link with the second coil Phi12 equal to K Phi1. So Phi12 equal to K is given 0.85 and Phi1 is given 0.3 milliweber. So answer
0.255.
0.255 into
10 raised to minus 3.
minus 3 Weber.
Hmm.
Okay.
Yes, sir.
Now we have to find mutual inductance. Mutual inductance. Okay, mutual inductance that we found. We need to find number of turns of second coil. So how to find number of turns of second coil? Anyone can tell me answer? Number of turns of second coil? You have this picture. Just see it. What relations that you are going to apply for finding number of turns of second coil?
M equals to N2 Phi12 upon I1.
Very good. M is equal to N2 Phi12 by I1. So N2 is equal to M I1 by Phi12. So 63.75 into 10 raised to minus 3 into 2 divided by 0.255 into 10 raised to minus 3. Okay.
500.
500.
500.
Yes, good. 500. It is 500. Okay, everyone getting this answer? 500. You
Yes,
can
sir.
write 500 tons, okay? It is dimensionless, but you can write it 500 tons. So you'll be asked this type of example, okay? So you need to remember these terms and their correlations. So accordingly, you can find out whatever parameters or data are given. So accordingly, you can correlate and find out these parameters. Okay. So still remain join in CSE2. I will inform you where on which date you have to change your class for this subject only. Okay, for this subject only.
Okay, sir.
Okay, I will inform you. Means on which date you have to change. If in other subject, if you ask to change, then you can change your class in other subjects. Okay, but for this subject, I will inform you on which date you have to change this class. Yes, Ria, any question?
No, sir. I just forgot to lower my hand.
Okay, okay. So you can leave this meeting.
Thank you, sir.
Thank you, sir.